Okay. So, welcome to our first case study of the afternoon. And this is Carl Petch from Telstra talking about the rise of IP. For those of you who don't know, there's a fairly significant IP video network within Australia and obviously far beyond. And this is a pretty exciting real-world application, so we're going to hear some good things about that. As a reminder, the videos from these presentations will be posted on VSF Top TV as well as the VSF YouTube channel. And if you get your badge scanned at the entrance, you'll be able to get an email with a link that tells you where to download the presentations, etc. So, without further ado, I'll turn it over to Carl, and we'll have a great presentation, I'm sure. Thank you.
Thank you. Thank you, everyone, for coming today. Just a little bit of background of who I am and who Telstra are, if people in the room don't know. I work for Telstra Broadcast Services. We're a wholly owned subsidiary of the Telstra Corporation, which is basically the biggest telco in Australia, and we're essentially that telco has lots of fibre in the ground and owns quite a lot of international subsea cables as well. And I work for the broadcast division that looks after servicing domestic and international clients, and I look after the architecture and the integration teams. And I think today what we want to talk about from a use case perspective is what's happening in especially down in Australia around the size of our continent and the way that customers want to drive costs down and how they've done that with remote production. We'll talk about certain use cases of that and why, from a technical perspective and from a commercial perspective as well, and why it's happening now. There we go. So we're going to focus on two specific use cases, and we did some testing quite a while ago on a 20,000 kilometre remote production. Plus, we did some international remote production out of Japan for some athletic events in this year. And we're going to talk a little bit about both. And I suppose, from my perspective, the international coverage of the athletics out of Japan was pretty amazing, actually, because we basically did remote production from Australia with all the camera feeds coming down out of Japan all the way through to Australia. The partner that had all the production equipment produced the feed in a traditional way, then handed it back, and we then sent that to Europe for essentially for distribution. Or rights holders taking. So that's quite an interesting one. And the other one was a lot of testing we've been doing around glass-to-glass, all IP, and I'll talk a bit about that too. Before we jump onto that, I suppose those use cases, just wanted to highlight there are many ways that you can do remote production, and we're seeing changes on a daily basis. I was talking to colleagues yesterday, and I've never seen so much change in our industry in the last 3 years compared to the last 15. So, and remote production is driving a lot of that change through all IP adoption. Just here, what we've got highlighted, a lot of these things will be talked about in the use cases. So we've done a lot of testing with TECO, which is a compression, can be lossless, can have some compression put on it as well. We in Australia have done full remote productions in an uncompressed, so essentially full 2110 streams. Now that takes a lot of bandwidth with the amount of cameras we're doing. In Australia, we do a lot of tier 1 and tier 1 sports over our digital production network, and most of that is done in uncompressed. And we do that over distances of 4,500 kilometres. And I'll talk about a couple of things that are important around doing it over those distances, like jitter and packet order and those kind of things. we talk about the breakthrough of doing remote production at great scale, and I think that's where the barriers are being broken down and the new business models are coming up. Is that we don't have to ship people to locations anymore, to venues to essentially produce a feed and then get it somewhere. We can bring it all back to a centralized hub, and people can then do that production there. And I think one of the key things for us is doing it in uncompressed. Doing it in uncompressed, it makes it easy because you don't have to have kit that compresses and decompresses. That equipment is getting, as you can see here, very sophisticated. But in uncompressed, it is much simpler, and we've done lots of testing through uncompressed. What I'm showing here is we were testing with a vendor. I think about a year ago. There's an event that starts this week in Japan, and we were doing some testing with that vendor across all of our links that we've got out of Japan. And essentially, what this shows here is essentially to make remote production happen, the network is the enabler. And I think from my point of view, the vendors now have the capability to built-in native IP into all of their products. One of the key things that helps it is building the network to facilitate that end-to-end control and data plane. And I think what we're showing here is we had a data plane and a control plane, and we also ran CCUs over this link, and it's basically native IP out of the camera all the way through to the destination in Europe from Japan. Just a little bit more detail here. As you can probably see, you can probably work out who the vendor was that we're working with. Essentially, what we did was a lot of Telstra's links around the world are built on OTN technology, and I'll come on to that. We just essentially carve up the OTN pipes into various chunks, and what's showed on this drawing is how we transported the different types of services across those OTN links. As you can see, we've got audio, we've got essentially metadata, which is essentially control layers and different trunks to do different things. This was, to highlight, this was 10 gig all the way from Japan back to the UK. So what we're going to show now is or talk about, which is the one that we actually put to air, which was the coverage of the World Relays out of Japan this year. Now, to make this happen, we need to work with partners, and the customer, ITN, wanted to do the production out of Australia. They felt that working with us and NEP, who we've built hubs for in Sydney and Melbourne, and essentially NEP services their clients in Australia with using our network to essentially produce live sporting events over our digital IP remote production network. They wanted to leverage those hubs they built for the domestic network to do international remote production, and I think that was the key thing. Now, this use case is slightly different to what we use in Australia, because in Australia we do a lot of uncompressed, and we have 50 gig on the A side and on the B side into most venues. So you do need quite a lot of bandwidth to do uncompressed. We would never get this from a commercial perspective from Japan into Sydney. So everything was done on a 10 gig pipe, and light compression was applied, and to some successful outcomes. Now, essentially, what we do is we work with the customer and their production partner, and we detail the requirements. As you can see, they wanted essentially 30 cameras. Here they were using Sony cameras. We had to build the network from Yokohama, which is just outside of Japan. We had to work with a local partner, Nexion, to build us the local loops into our main POPs. We still had to build that type of infrastructure to the venue. I should have put some photos in, actually. We had the partner that provided the local loops rocked up in a van. They had the fiber in the venue, and they connected it into their network here, connected it to their network into their network in Japan, and then delivered it to our POPs for us. And then they handed off the interface, which is 10 gig, and then we put it into our network. Now, from an assurance perspective, when working with the customer, we needed to put an edge equipment in front of the local loop. This is more to manage the customer and how they onboard into the network. Through our discoveries in Australia, we need to work with the customer quite detailed on what VLANs are using. You really do have to put a lot of effort into understanding what the network's going to do and how the production partner interfaces with our network, and we basically spent a lot of time when we were building these networks around what does the network look like from a config perspective. So we have edge devices that we stick in front of the local loop, and it's a well-known interface. The customer then plugs into that, and then through the bookings process, we essentially assign VLANs and those types of things. So the production provider rocks up, plugs in, and should come up automatically. They've applied their config, and it just all flows through the network. So what makes this happen? Essentially, Telstra's invested a lot in the last kind of 5 or 6 years in optical transport networks, and the low-level transmission is where this is essentially how we can deliver it. We use OTN, and I'm going to talk about OTN a bit more, but I think one of the key things that NEP used to get their camera backs from Japan was using VC2, and I think the VC2 low latency compression that their vendor uses has proven successful out in the wild, and they do a lot of events using that technology. Little bit boring, but I just wanted to highlight some of the latencies, and it's very important that we understand the latencies when trying to do international remote production. We've got, and also the amount of different cables and segments we use to deliver all of the feeds, basically. Wanted to talk about what are the main challenges when doing remote production. One of the things that we've had a lot of discussion in as the teams and is understanding Jitter and making sure that we understand how to actually calculate it and talk about it. We in Australia decided on due to the distances and those types of things, that we would only handle 7 milliseconds of jitter, and we did a lot of testing with our partners around what that looks like. It's very important for us to get that right. So as I said earlier, OTN is what's driving our ability to give these types of bandwidths to customers in unheard of capacity, essentially. I talked earlier about how NEP in Australia on our DPN uses 50 gig out of a venue, and the only way that we can do that is through optical networking. And Telstra, the mothership, has chosen OTN to provide modern new services. And as you can see here through this diagram, high-speed internet can be delivered over, high-speed Ethernet can be delivered over that in different flavors, and we can chunk it up and we can do different things with it. And I think that's the enabler for us to essentially do IP remote production, especially internationally as well, where our whole network is transitioning over to OTN. What I'm trying to showcase here is around the bandwidths and the ever-consuming approach that people just want to consume more and more bandwidth. And just wanted to highlight the types of figures and around where we're going to end up being in, say, 5 years' time. With OTN, we can scale in 100 gig increments. I was a big user of SDH back in the day, and I see that was very reliable and very stable. OTN is exactly the same and is delivering bandwidths that are unheard of internationally as well as domestically for us. What I'm trying to show here is the scalability and the simplicity for reliable remote production networks and what we can do over them. And I'm just trying to essentially show the electrical domains and optical domains in and around how we transport a signal, and also the different types of services over the OTN multiplexing. Oh, there you go. So just want to talk a little bit about where we started to use OTN on the international networks. We did some work in Pyeongchang for some rights holders, and we put in a lot of dual and diverse meet-me points in and around South Korea, and the Telstra supplied the OTN network to facilitate a lot of the transport of the content out of Pyeongchang. From a result perspective, we also had challenges in that region where we had multiple incidents like earthquakes and that kind of stuff, and the rerouting of the traffic that we needed to do, and that was done quickly and efficiently using OTN. We use OTN a lot for women's tennis, and we've got a lot of, we roll out, well, essentially spin-up services over our OTN network to deliver spin-up, spin-down IP networks for various use cases. This one is for tennis, where they go to an event for a week, they pack up, and then we move on to the next one. We do about 50 to 60 a year. And the one that I've touched upon is the remote production for Fox Sports Australia, where the demand for tier 1 sport and to reduce cost has essentially allowed us to build a dedicated IP network just for remote production, and using near uncompressed workflows. And I think that the scale of that, so essentially each venue has 50 gig coming out on the A and the red and the blue paths, but our core needs to be at a scale to handle multiple events at once. So we've got the capability to do 200-300 gig in the core, because we can do up to 7 concurrent events at the hubs. And I think that's where I think everyone would want to see remote production in the future internationally getting to, is where we can concurrently do lots of things at once over IP networks. And I suppose I'm going to say this, but the only way that you can do that is through the network, and the network is the enabler. And the challenges of that are making sure that you have configured it correctly, and also talked with the customer and how they want to use it, because you're in the world of service providers, making sure that you understand what the requirements are is very important. And I think the key thing about why remote production in Australia was so successful, it wasn't necessarily about the technology, it was more around the commercial construct to build a dedicated IP network. And I think we shouldn't focus all on the technology. The certain business cases that allow this to happen, to make the change, is all about the commercials and driving efficiencies. What time is it? 20 past. Just wanted to talk around why we believe OTN should be used. It is very open and very simple to deploy. It supports a lot of different things. We have various different vendors that can give us OTN, where we've been looking for different partners to give us OTN handoffs. It's very easy to do metro and efficient long-haul networks, very granular to go down into small bandwidths to large bandwidths. and it's actually very good for media transport. And we've proven that with all the tests we've done and the networks that we've built over the top of it. Just wanted to finish up with some questions and some if anyone has any questions.
So, yes, if anybody has any questions, that would be great. Carl, quick, my first impression, what has been a bigger factor for you, the availability of bandwidth on the network or availability of the technology to put at either end of the network? What's been more of a struggle?
I think the bandwidth has become available because of the choices that the telco's made in and around its network, but the struggles have been the integrating of essentially production equipment in with the network and it all talking seamlessly. They're the challenges, and the config of the network and how you interact with essentially foreign entities on your network and how you do the transactions of VLANs and those types of things. We've spent a lot of time always talking about that.
I believe it, yeah. Anybody else have any questions or any comments? All righty. Well, thank you very much. Appreciate it.
Thank you.
So we will be starting our next presentation in about 6 or 7 minutes. Feel free to relax here. Also, you can take a look at some of the displays that are around the room. And we'll have everything posted within the next week or two. So be sure to check out vsf.tv and get your name scanned at the front desk. So we'll be starting soon.